the whole world is interested, I guess, because I read so many high-level professors, scientists are interested about your work. Can you explain in a citizen level of speaking, what are you doing here? I mean, of course I know, but we need to tell the story to regular people, regular citizens.
Okay. First of all, there is this community called the free energy community worldwide. It's a loose community, and they are trying to integrate, the potential that is in empty space into their invention. The concept is from quantum mechanics. It says that empty space is not empty. Even the space, in between Earth and Moon and between the galaxies looks empty to the eye, but it is not empty. There is a so-called quantum potential that's called the quantum vacuum. So that vacuum out there in space is not totally empty. It's not nothing, but there is something. And the concept is that the electromagnetic fields interact with that field because the field exists as a structural property of space, and therefore the potential in space plays a role in every electromagnetic system. So this free energy community is trying to build inventions and come up with stuff to integrate this energy, and then the story is, we need a system that somehow resonates with the energy in the quantum vacuum, and then we can get out more than we put in a thermodynamic sense. That's fair enough, but it doesn't work that way. We have to start somewhere else. So what I did in 1999, thanks to my mentor, Dr. Thomas Bearden, a nuclear physicist from Huntsville in Alabama, who was the leading theorist in that field. Unfortunately, he passed away in 2023 or 22. The thing is, we have to start at a different level. We first have to understand how does a conventional electric circuit work. Now, thermodynamists and electrical engineers think they know how such a system works, but I do not agree. Because it is said, we have a power station out there, a coal or nuclear power station out there, and we have the lights in our living room. And the electrical engineer and physicist will tell us that that power station out there supplies the energy to this light. And that is totally wrong. That is not what is happening. So what I did is I invested 10 years of my research to understand how regular a common electrical system works. And it's not easy. I can explain it now once you got it in easy words so everyone can understand it. But you have to understand the interaction with space, because every electron, every electric and magnetic charge interacts with space, and the energy in first instance always comes from the structure of space. So what happens is the following. In the power station, we are burning coal. And when we are burning coal, we are turning a generator. And when we are turning a generator, we are separating the charges. We are pushing electrons to one side of the coal, and on the other side we have the positive charges. Now that creates a voltage. But what is a voltage and what creates it? It's the electron itself. And that opens up a door to the field of the electrons, of the electromagnetic field. So the energy in the power station does not come from the power station, it comes from space. So we are burning coal in the power station to open up a door in the power station. Then energy from space flows into our electrical circuit, to our light, and then the electrons, because it's a circuit, are pumped back to the power station, and there it is closing the door again. But when the door is closed, the energy input from space ceases, and then nothing happens. So what must we do? We must continue to burn coal to hold upright the door in an open way all the time to use that energy. So the idea was, how can we invest a little bit of coal, so to speak, open the door once, and then we put the foot into the door and leave it open. And that is possible by using the energy of space itself to do that. And that needs now a new system intelligence. And with a normal thermodynamic system, you can't do that just like that. You need access to quantum fluctuations. Quantum fluctuations is also a potential that exists in space. And to get access to that, you need a so-called quantum critical system that is tuned to its quantum critical point. And there are crystals known, for example, in quantum paraelectric materials that are tuned to a non-zero quantum critical phase transition. That's what we are working today. I will not go further into that. That's a bit too advanced for that interview. And but there is one molecule which is standing clearly out of all other molecules that has access to quantum fluctuations, not at super cold temperatures, but at room temperature, and that is water. And that explains, or via this view, you can explain the so-called Mpemba effect. The Mpemba effect is an effect that was discovered by a guy in Tanzania, a guy who has no knowledge about physics because a physics professor would never come up with that idea. So that guy was a teacher in a school and he wanted to sell ice cream. So what did he do? He put a cup of hot water and a cup of normal room temperature water into the deep freeze at the same time. And then he watched which water freezes faster. And he saw that the hot water freezes faster than the cold water. Now, from a thermodynamic point of view, it doesn't make sense at all. It is totally counterintuitive, and it must be false. Yeah? But it's true. It happens that way. And we can explain now how that works. Water has between sort of 4 degrees Celsius and up to 37 degrees Celsius, our blood temperature, the best access to quantum fluctuations. And when you heat water further up, it is hotter, so thermodynamically it has more energy, but that water has less access to quantum fluctuations. And there's an imprint into the oscillatory behavior of the molecules. So when you cool down hot water, it just cools down normally, you just take away the heat, but the extra energy input from the quantum fluctuations is not there. That's why you can cool down hot water easier. And when water has sort of 25 degrees Celsius, maybe up to 34-ish, 37-ish degrees Celsius, it has a very good access to quantum fluctuations, and that's why it takes longer to cool it down. And the interesting thing is here on these crystal cells, they work best up to 37 degrees Celsius. So between 20, well, that's the colder it gets, the less energy they have. The warmer it gets, the more power they have. But at 37 degrees Celsius, it cuts completely off. And that's a repeatable experiment. So the quantum critical nature of the water molecules that is inbound in the crystal structure that is between the plus and minus electrode creates that. So what is this? At that time, I experimented with all sorts of crystals, and I went to a shop where they sell minerals and crystals, and I just measured the voltage. Is there something to see? And I found, and in calcit, for example, you can find places where you can measure with 0.2 volts or something like that. It depends. And then I started experimenting with a polycrystalline silicate. And this material is most likely a zeolite. It's based upon sodium metasilicate nonhydrate, 9-hydrate, and that is processed in a chemical reaction and then put inside here. And then we have a coated copper electrode, and that's aluminium doped with silicon, 0.5%, so that's not a normal aluminium. And these cells produce a small voltage of 1.3 volts about, and a small electrical current of up to 1 milliamp. And these cells are dead short resistance. You can connect the plus pole with the minus pole for years, and you can disconnect this wiring, and then it will work as before. So you can't kill them. You can't empty them because there is no energy inside. They don't store energy like a battery or a capacitor. It's an energy converter, not an energy storage device, which you then dissipate afterwards. You know? And so this light here on my oldest cells is running now since 25 years. And yeah, and in the meantime, there are universities involved in the research. One is the Technion University in Israel. One is the university in Georgia, in Kutaisi, under the leadership of Professor Amiran Absiptari. And in 2015, I've sent him a few of my cells, and they tested them at the university with his colleagues. And to make a long story short, they came to the conclusion that this technology is not a battery from their view. And I was nominated for the Japan Prize in December 2023 by Professor Tengiz Yalishvili. The pronunciation of Georgian names is really tough. So, and he's the leader at the chief scientist of Georgia, basically in Tbilisi.
So basically, the scientific circles see very big potential.
Yes, more and more. Yeah.
I mean, if you are nominated for that Japanese prize, innovation prize, yeah.
Yeah.
So there must be some kind of way to acknowledge your work, actually. But what about the bigger energy, more amount of energy? How can you I mean, do you need more material to produce more energy, or how do you go with that? You know what I mean?
Well, yeah, that's one way to do, but that would not be efficient or economically. At current power density, it doesn't make sense, because if we wanted to power a home, we would need so many cells. It would be as big as the home itself, so that it would be very costly and it would be a big mission. So we are doing our research about increasing the power density, the ratio between volume and power, and we're trying to get it up. And if we manage to get it up, then depending on the power level, we will be able to power a very low power application. Actually, there is already one application that we could power now. Every home now in Germany has these smoke detectors on the ceiling, and they need a battery, and that battery must be replaced after 10 years because the power consumption is very low. It's 1/4 of a milliwatt. And so what could be done is to charge a capacitor with one of these cells, and then when the alarm goes off, then the alarm is discharged by the capacitor, which can give a high current load. So that will be one application. So with every milliwatts that comes extra, we could build a torch, for example. The example with household torches, you know that you never need a household torch. It's always lying around. Yeah. And then after 5 years, you have some problem, the fuse goes out, you're getting a torch and you find, oh, the battery is empty because batteries just empty on their own, And we could build a household torch also with a capacitor and a cell, and the cell just keeps the capacitor charged over decades, and then so that will be also an application that we could realize now.
Okay, it sounds amazing, but what are the major obstacles now in your research? I mean, there must be some kind of challenge that you need to overcome.
Yes, well, that is improving the quality of the silicate material that is in here. That is improving the coatings, because these are coatings that have the characteristic of a Schottky diode. I'm not saying it is a Schottky diode, but it behaves as if it was a diode. So you can visualize like that. You have the two electrodes. This is the circuit. You have the light bulb here and the wires. The minus pole is here, and the electrons move from the minus pole to the plus pole. And here in the middle is the silicate. And on the interface between the plus pole and the silicate, you have a diode. So the electrons can move only in this direction, but don't go back, like in a valve. That's what a diode is. And here we have a reversed valve or reversed diode. Here the electrons can move from the silicate to the metal, but not back. And since the silicate contains water molecules, which have access to quantum fluctuations at room temperature, this vibration causes the charges to move back and forth, and the charges that are moved over this diode barrier, they can't go back, and that's how you separate the charges. It's like it can be seen like an internal photoelectric effect, like a solar cell, but it's a solar cell that doesn't need the sunlight to operate. It's a solar cell that needs only the natural quantum fluctuations and atomic and molecular vibrations to separate the charges.
This innovation can change a lot in the future.
Oh,
I mean, it's a green energy, but you can like influence companies who are really establishing their producing the normal way of batteries and more. So how do you see or how these companies see the place on the market tomorrow, for example?
It depends on the power density. The power density will determine what markets can be supplied. First of all, regarding the power companies today and the established scientific community, first of all, a consciousness must develop that these technologies are possible. And as science fiction as this sounds, but since 2023, there is very interesting information, which I have on that screen, by the way, right now, if you want to have a look at it. It was published in September 2023 in Nature magazine, and you're aware what Nature magazine is, making an experiment with a so-called quantum piston engine with a lithium 6 isotope gas at very low temperatures that is triggered with a laser. And so the energy input, the thermodynamic energy input is very small, but since the gas changes from a fermionic to a bosonic state and back, it can create an expansion and contraction. And the energy, the real energy for this expansion and contraction comes from the quantum fluctuations. So these systems cannot be thermodynamically explained. These are engines that are quantum open systems that integrate excess energy or energy from the quantum fluctuations and therefore run permanently on their own. They have a perpetual characteristic, but that has nothing to do with perpetual motion. Perpetual motion is not possible. Perpetual motion is a concept that relates to Newton's work, and that's a thermodynamic concept. And in thermodynamic systems, you will not be able to create excess energy. You can't create energy from nothing. You need to open the door. You need an external source of energy to be integrated, and that is possible via quantum critical materials like water at room temperature. And that's what we are doing here, in the material.
So it can be used in everyday life and in every aspect, as you mentioned before. And is there any kind of higher usage of this invention? I mean, for some kind of, bigger things like bigger machinery?
Not at this stage, because the power density is not strong enough. It's not doable. In practical sense, I have to answer that with a no. But it is clear, number one, integrating energy from space works. Number two, it will be the future of energy generation. I cannot say when. It's a process like everything, but there is no question this is the holy grail of energy production. And number three is, what must be done is we have to continue the research to understand the materials in a better way so we can get access to more energy. The third thing is the energy density in space in an unlimited or on a point in space is infinitely high. So there is no question about the energy. It's not an energy question. It's just a question of how do we get access to it. And the more asymmetric our system operates, the more quantum open it behaves. So our research must focus upon the asymmetric property of the system intelligence of our device of interest, and that will determine how powerful they are. And that's, the theoretical concepts are there. There is no lack on ideas. It's really a lack of funding. And the problem is, we had, for example, 1 year ago, we tried to apply for funds at the European Union, and there were 3 gentlemen who were approving our claims with this technology here. And and one said, yeah, interesting, that might be possible. And the other 2 said, straight out, they said, this is not possible because it does not harmonize with thermodynamics. Well, of course not. We're dealing with a quantum open system that cannot be described thermodynamically. That's what we already said. And they said, our claims are wrong. It can't work. So they're just saying what we are saying is flat out false. And that is, I mean, it's ridiculous. You know, we are trying to improve the environmental situation on the world. I have dedicated my career to it the last 25 years, since 1998, you know, and then I have to, you know, listen to something like that. It's embarrassing that this is. So the problem is really, we need massive funding on quantum open systems. Give you another example. Since the 50s or 60s, there is research in hot fusion. And I think far over $100 billion went into that research already. I think it's around $200 billion up today. So from the 60s to 2025, where are we? They are saying today, well, maybe it takes another 50 years until we get it. But if we get it, we don't know. Yeah. So what must be done with this here, which is a much better approach, because we are not trying to thermodynamically crash atoms with brute force. This is working in harmony with nature, with life. Life forms also use quantum fluctuations as an information field to create the phenomenon of, you know, self-organization and all that, and consciousness. So we need an extended understanding of how nature works, and it needs much more courage and open-mindedness from the established scientific community, that thermodynamics is not the whole story. I mean, it's in the literature that quantum open systems are researched at several universities, and that's a reality. And a quantum open system, again, as I mentioned before, cannot be described by thermodynamics, period.
So the scientific circles, I mean, are watching you in your innovations as a high school guy. I mean, not high school guy like you are going to high school now, but you don't have like level of education like scientific circles have.
Yeah.
How did you come to that point when they start to acknowledge your quality, and of course to get to that point to be nominated for that Japanese prize?
Yeah. Well, two things happened in the last 4 years. In 2015, I sent these cells, as I said, to the university in Georgia, and they were investigating it, and they needed 9 years to understand that this is for real. And then they, at some stage, also looked at my theoretical views, because I'm using right from the beginning a quantum open system perspective. And thanks to my genius mentor, Dr. Thomas Bearden, I was able to step into that field with fresh eyes. So it was an advantage. That's what I'm not saying that, but everyone who knows me, every physicist, every electrical engineer tells me it's an advantage that I never studied at a university. I mean, physics at least. Maybe something else would have been of help, of course. And because this is not about understanding a new concept. This is really about shifting the point of perspective. And I'll give you now a simple example what that means. Let's say I have a cube here between us, a cube. And the cube is from your side blue and from my side yellow. And let's say this is reality. This is the phenomenon of electromagnetism. Now you look at this and you say it's blue. And you said you're telling the truth, you're not lying. And I say, hey folks, this is yellow. And I'm also telling the truth, I'm not lying. But our opinions, the outcome is totally different. And that's the difference between classical thermodynamics and applying a quantum open system perspective. It really needs a shift in your consciousness and its practice. You really need to exercise it to get away from the mechanical worldview. My starting point of observation is in empty space. And from empty space, I go to the atom, via the field to the atom. And the atom is only made up from space. The atom does not exist as a structure. And physicists often come up with an example that is a bit misleading. They say, the nucleus is, let's say the nucleus is the size of an orange, then the electron is, 150 meters away, and between that we have empty space, so most of the volume of the atom is empty space. Okay, fair enough. But there are two things to add here. First of all, the electron is a point charge. So it's an unlimited small point that has a field and a mass. So, and a point charge has no size. So the electron does not exist as a thing. It is a quality of space-time. So now you think, okay, if that's a point charge, then what about, this orange in the middle, the nucleus? Well, this thing is the same thing. The nucleus is made up from neutrons and protons. And a neutron and proton is made up of 3 quarks. And a quark is a point charge as well. So there is no orange in the middle. Yeah, we have to think space-wise and not thing-wise. There is no sharp surface. If I look from here to my hand, I see a sharp surface. But when you zoom in, you will see only field. It's only a change in the quality of the structure of space-time itself. So if we want to understand what mass is and what an electromagnetic field is, we first of all need to understand what is empty space. And that is the key. And it takes a long time to understand, hey, empty space, there is nothing. And you cannot make something from nothing. And now it gets even more interesting. Physicists often say, you cannot make something from nothing. Sounds ridiculously logical, isn't it? Well, because they say, well, something is something and nothing is nothing at all. So how do you want to make something from nothing? It just doesn't make sense. Well, that's fair enough, but I'm afraid there's a logical error in that thought. Because the structure of our logical thinking is based upon the Aristotelian concept of dualistic logic. What does it mean? It means left is here and right is here. That's the opposite. Anyway, left is an observable and right is an observable. I can see both things and that's an opposition. You can go up, down, up is an observable, down, black and white. Yeah, you can see black, you can see white, both observables, and you put it in oppositions, or right or wrong, or good or bad, or that's how we think. Now we come to the situation, something and nothing. We put them into opposition, but we are not allowed to do that. Why? Something is an observable, but nothing is not an observable. So before we think ourselves into the nothing domain, we have to program our consciousness with a non-dualistic concept of logic. So what does non-dualistic logic mean? Non-dualistic logic means that here and there and everywhere is the same thing. You cannot separate it. It's non-dual. And it means standstill, some speed, light speed, unlimited speed. It's the same. You cannot separate it. And it also means that no energy, some energy, unlimited energy is also the same. Now, what does that mean? That means that nothing is absolute in its potential. Why? Because nothing is not nothing. It's the presence of non-dualistic logic. And if nothing is the presence of non-dualistic logic, it must be absolute in its potential. And that's where it starts. Yeah. So, and there's another thought to it. Let's say the universe had a beginning. Big Bang, maybe before the Big Bang were some quantum fluctuation. No, but let's take the very beginning of the cosmos as a whole, no matter how far you go back. If there was a beginning, then before there was not really nothing at all. Yeah. But who in hell determines when and how something is made from nothing? That doesn't make sense. So nothing in the sense of being nothing at all, that doesn't exist. Yeah. And that is where we have to evolve our consciousness. And that's a part of that, because these quantum fluctuations, these virtual particles that come up everywhere in space, these are logic fluctuations from a non-dualistic logic into a dualistic logic. And that is the frame, that's the phenomenon that creates the flow of time. And that's why I developed a time-based foundation of physics. And upon that time-based foundation of physics, I developed the time-based theory of electromagnetism. Based upon that, I developed the concept of asymmetric electric systems, and based upon that, I developed the hypothesis for this technology and the FCO, what we are working on with the ceramics, and about a dozen other hypotheses for other inventions that I would like to make or work on, but fortunately we don't have the funds for it.
What is waiting you now? I mean, you said you are working on that research of materials and everything else. Yeah. So what is the future of your research? Can you project a little bit? Can you tell a little bit more what is waiting for you now?
We can only continue if we have the funding.
And so, of course, one more thing. Do you have so often like that end, and then you need to go another way?
Oh yeah, yeah. I change my course often. What we are doing is very basic research, and failing is my daily job. And you need the right mindset to deal with it psychologically. It's you need the right personality to do that. You need a vision. I'll give you an example. Edison, I think he built over 3,000 light bulbs until he got the right thing, you know. So you need to be you have to be able to handle the failures. But these failures are not really complete failures. It's a part of the learning process. But that's simply how basic research works. It's everywhere the same thing, basically. So what we are doing now is we are improving currently the quality of that silicate structure. It's most likely a zeolite structure that contains water molecules. And we are improving the coatings that have a diode characteristic on the plus and minus poles or interfaces. So that is one part. And the other part is with the ferroelectric materials, which are based on a PZT, a lead zirconia titanate crystal, which is containing strontium. It's called PSZT. It's lead strontium zirconia titanate. And strontium titanate is a so-called quantum paraelectric perovskite. And due to the quantum paraelectric properties, we are convinced that you can integrate excess energy from quantum fluctuations at room temperature. And it must be possible at room temperature because the Debye temperature of strontium titanate is well above room temperature. And so that is our research. We want to increase the power density on one of our approaches. And if that is achieved, then we will have access to really big funds. And that is my dream, because I want to build up a big lab with several teams to realize these technologies. And as I said, I mean, this is, it's still very low, but using quantum fluctuations as a source of energy is the holy grail of energy production. It is emission-free, it is in line with nature, and it's going to be the future. It's just a question of time, really.
Let's talk about funding. I mean, you must have some funds until now, but you need more. Who can provide that? I mean, German government, European Union, I mean, the whole world should invest in this. That's my opinion, because I can see the potential is huge, really.
I completely agree with you. Everyone should invest in here. And that is what the energy companies should do, what the governments should do, and the universities should do. But again, what the problem is, it's the mindset. Their thinking is constrained by thermodynamics. And they think, oh, if you get out more than you put in, it's perpetual motion. No, it's not. It's a quantum open system, like a solar cell is an open system that takes the sunlight as an external source of energy. And we are taking the quantum fluctuations that emanate everywhere in space as an external source of energy. Yeah. So, and this must be understood, but it's sort of human nature. Even quantum theorists often say they hate quantum mechanics, because it's like a weird world that is counterintuitive. And it can't be understood. Well, it can be understood. The basic nature can be understood, but you have to be ready to change your point of perspective from that side of the cube to that side of the cube. And that is the challenge.
At this moment, I see one team member here. Do you have more people? And are you open to get involved, people who are interested to cooperate?
Yes, we had.
How did you find him?
Well, that's actually an interesting story. In January 2020, yeah, but that's later. I was invited by MIT in Boston to give a talk, and I gave my talk, and it went down very well. And then in 2022, there was again this the how to say congress or a fair, it's called the Unlab Unlimited Liability, which is held at MIT, and the most promising research projects from Stanford and other universities were presented there at MIT. And but in 2022, I did not present my stuff. I was just listening. Anyway, Eric was writing a master thesis at the Technical University in Munich about these quantum open systems that were presented at MIT. And he also then learned about our work and interviewed me and the others. And yeah, and so that's how the master's thesis came along. Yeah. And that's how we met, and then yeah, things came together. I have another employee, that's Eckhard Kant. He's an engineer for energy technologies, but also a superb electronicist and software engineer. So we are three in the base group, and then Christian is our company and doing all the invoices and that stuff. And then we have our investors, our private investors from Florida. Very nice people, spiritual people, by the way. They can afford it, what we are doing here, and they are not only doing it for the money, otherwise it would not work. They are doing it because they want to do good to the world, and that is believable in that case, because that gentleman is also financing, I think, a part of the Mind and Life Institute from the Dalai Lama. They are friends. And so he's involved in humanitarian projects, and so it's very nice to have these partners, because we are working together since 2015, and yeah, we were hoping to get to better results in a quicker way, which we didn't, but we are still in very good terms, and we have a very open and frequent relationship and communication ship. And but yeah, what we are doing here is, I mean, according to the project, small, and we need 20 times the amount per month, to get going. We need a team of 50 people, or to do that. We need the universities, we need the academia to work out the details, because this is it's like hot fusion. They're putting in billions. I mean, you should put the same amount or even more into that research, because this is it. Yeah.
Is there anything important that I didn't ask and that you want to say?
Yes. What fascinates me a lot is this is not only about generating energy, electromagnetic energy. As I got along over the years, we found that a better theoretical understanding of what the quantum vacuum and the quantum fluctuations is, we learned that these quantum fluctuations play a decisive and fundamental role in living organisms. And living organisms have a soul. And I wanted to understand, what is the soul? What is an intuition? What is an emotion? How exactly does that work? And in January 2020, I came across a work by Professor Stuart Hameroff and Sir Roger Penrose, a Nobel Prize winner. And they were describing the microtubules in brain cells, now in neurons. Now you have neurons, and neurons fire and do the thought process, as far as neurologists say. But the point is that the neurons are filled with a microtubule network, and these microtubules are filled with water. And these microtubules, they oscillate with 68 terahertz or 63 terahertz, And these molecules are quantum critical molecules at room temperature, at 37 degrees Celsius to be precise. And so microtubules with this terahertz frequency picks up permanently energy from quantum fluctuations from the domain where our soul exists, transfers it to the microtubules, that changes the frequency pattern like a guitar string, same like music. And when a few or enough microtubules do the same thing at the same time, then the microtubules determine when the brain cells fires an impulse into what direction. And that's very interesting. I'll give you an example of what that means in concrete terms. Let's say I'm sitting in a lab and there's a screen, and then you have a green point coming up on the screen, and I see the green point. The information goes into my eye, and then nothing happens. Then suddenly, 3/10 of a second later, which is a long time, brain cells start firing at the back of my head, but simultaneously at different places at the back of the head without any chemical connection. And then that's the first wave. Then you have a second wave where they're firing here, and then a third wave which arrives here. And when this pattern arrives here in the frontal part of the brain, then we become conscious of that green point. And now neurologists have found that what we are experiencing here, we are already aware of that, and we can react to a certain impulse before we are conscious of that thing. And that's why neurologists say our thoughts are pre-thought by some other entity. So we are not free. We have no own free will. Now, and by understanding better what happens, we can say that's wrong. We have a free will, 100%. Because what happens is, let's say you're looking at the screen, the green point comes up, that information goes into your eye, and via the cells in the eye, it goes directly to the domain of quantum fluctuations where my soul exists and my true I identity exists. Then my soul processes that information and creates an intention. The intention is then, via a quantum critical reflection, screened back to my brain cells, and then they start firing. But that is my decision. I'm just not aware that I have made that decision because I am not living here in this reality. Our body is just like a car that we are driving, but our soul is the driver in the car. And that's interesting because if we speak about incarnation, birth and death, these phrases are not optimal. They are okay, I can live with it, but we are never incarnating in that way. We are never sort of born from nothing in this. When we are born, the only thing that happens is we are shifting the focus of intention from the quantum domain into this thermodynamic body. Then we stay here for 90 years or whatever. And when I die, I'm just shifting the focus of intention back to the quantum fluctuations where we are all the time anyway. So we are not born and we are not dying. We just think we are born and we are dying. We have just shifted the focus of intention from the quantum domain into a thermodynamic reality, staying here for a while, then shifting it back again. And that we can explain physically how telepathy works. And it's easy. Once you have recognized that the quantum fluctuations is a domain where you have superfluidity, superconductivity, and where you have a non-local, spreading of information, and that's how human minds or animal minds, they are connected all the time in zero time. It works instantaneously, faster than the speed of light. And some people have better access to it, and they can feel other people like you can do that, I believe, and that's how plants can feel our intentions. It's a total reality, and that's just the tip of the iceberg. It goes way deeper than that, but I just would be too much for the video now. Yeah.
So thank you very much.